Hello all and welcome to my YouTube channel. Welcome to this series of LangGraph where we are learning the LangGraph in depth. This is the fifth video in this series, and in the previous 4 videos we have already covered the basics of LangGraph along with the conditional statements, the LangGraph memory management and the streaming responses in LangGraph. In this particular video, the focus will be on human in the loop interruption in LangGraph. Let's understand what exactly is the human in the loop, HITL, and why it is important. So human in the loop meaning whenever we are building any AI applications, we are requesting human to interrupt in between and take a call or a decision so that the AI workflow goes smooth. In most of the cases, wherever we are building a complex AI systems or where it is very much important that we need to be depend on the human validation. So in those cases, we go for the human in the loop interruption. Now, let's understand what are those scenarios and how exactly it works. So what exactly is the human in the loop? It is an human oversight that we introduced in the AI application or workflow. So instead of the AI executing all tool calls automatically, the system pauses at predefined points and waits for human confirmation, modification, or rejection. So this is important, human confirmation, meaning we are allowing human to take a call whether to go ahead or not. Modification, if let's say the AI workflow is making some mistake, then you can go ahead and modify that particular part and then you can continue the workflow execution. Or you can reject if you think that, okay, the workflow is not going in right direction, you can reject those. That's where the human in the loop is important. So in LangGraph, we can do this with the help of this simple feasibility that they have given. Interrupt before equals to tool. We just need to define this in the workflow and we'll be able to add the interruption. Now let's understand why exactly it is important. So first of all, in order to prevent the error, because the AI may misinterpret some of the information and it may incorrectly call tools. So in those cases, in order to avoid that, we should have an human in the loop wherever it is required. So for example, we will be seeing an shopping cart example and there it will be clear for you. I'll explain that example. Second one is the transparency. So human can see what AI is about to do before it executes. So human are always in confidence whether the workflow is going in correct direction or not. That's where it gives more transparency for the human. Then control, it allows business critical decisions to stay under human authority. In most of the cases, whenever you are dealing with a critical business and you don't want to blindly trust on AI applications to take a decision, in those cases, you can have an business, you can manage the business critical decisions. You can route those decisions to the human so that human can approve it before generating the final response. And compliance, because it is very useful in industries where AI cannot act without human approval. Few examples like finance, healthcare, procurement, where you cannot blindly trust on the AI applications. Though your AI application accuracy is way better, or though your AI application is performing very good, still you cannot rely completely on the AI. You should have some validation layer in between, and that is what we are trying to integrate in the our LangGraph agent. So these are the goals. So first, we are going to see the approval state in this particular video, and in upcoming videos, we'll see how exactly debugging and editing is possible in the LangGraph node. So as we have mentioned here, we will be using this interrupt before in order to add the interruption. So let's see how exactly it works. Okay, so before going for the human approval, first of all, we need to add the breakpoints so that we need to break the continuous flow that is happening. The one agent is calling multiple tools or multiple agents. That flow we need to break. And how we can add that we have already seen that we can simply introduce this particular terminology. And we'll be seeing one very simple example. We'll be seeing an example of shopping agent where user is going to ask question to our agent and agent is going to interact with user, as well as it will extract the relevant details by interacting with the tools that are available. Let's say if user is asking a question, can you calculate the bill for one apple, one bread and two chocolates? Very simple question. Now, the system that we are building is a shopping agent where this agent has access to these different tools. Check price is one of the tool, add to cart is another tool, and calculate total price. Those are the three tools that we have. Now, and then once we get the answer, it is ending the conversation. Very simple workflow that we are going to build. Now let's say for this particular question, first the agent should decide that what kind of tools it needs to call whether a single tool is sufficient to answer this user question or it needs to call multiple tools. So in this case, first of all, we have given a type of entities for which we want to calculate the bill along with the quantity. So definitely the agent is going to call check price tool because it will give us the individual prices for these individual item, and then it should call the calculate total in order to calculate the total price. So that's how these two tools are important in order to answer this response. Now, if you don't add interruptions, this workflow will go ahead and extract the details. But as it needs to call only these two tools, but if you have three tools given, there are chances your AI may make mistake and unnecessarily it should not misinterpret it. And instead of calculating the bill, it should not go ahead and add one bread, one apple, and two chocolates into the inventory by calling this add to cart tool. If that happens, you are screwed. Your workflow is screwed, right? And that's where in this particular place you are going to add the interruption. So whenever this particular agent starts the execution with tools, it will interrupt the flow and then it will ask for an human input confirmation or approval to go ahead. And once, let's say first it calls the check price tool, then it will give that response to agent. Again, it will call the second tool. So at that time, again, it will ask for human approval, and in that case, you can check whether the check price tool was called or not, and now what tool it is calling, and accordingly, you are very sure that okay, the AI is not making mistakes, and you are going to get the accurate answer. This is applicable for critical businesses, as I mentioned earlier. This is very simple example that we are covering just to give you the idea how exactly this happens behind the scene. And at the end of this particular series, I'm going to cover an end-to-end project where we will be seeing such real-time example, why it is important, these breaking points and the memory management, whatever topics that we are covering, everything we will be covering in the end-to-end project. So please stay tuned for that. So let's go ahead and start coding how exactly we are going to build this particular workflow. Also, at the end of this video, we will be covering an LangGraph Studio. So please watch this particular video till the end because we are going to cover both the LangGraph agents that we are going to build, and manually we'll be adding this interruption. Plus, we'll be adding the interruptions on LangGraph Studio. So how exactly it will happen? Let's go ahead and see that. Okay, so first of all, we will be importing the large language model. Just like the previous video, in the streaming video, we have imported the large language model from Azure. So similarly, we'll be importing a Azure OpenAI from the Azure Foundry portal. So let me go ahead and show you that. So let's go ahead and import the necessary dependencies first. So we'll be using LangChain OpenAI, and from there we'll be importing Azure OpenAI because we are going to consume the model from Azure, and then we'll be importing a chat prompt template from LangChain. Now let's go ahead and define the large language model. So defining large language model again is very easy. So we'll be calling this particular Azure Chat OpenAI class, and there we will be defining Azure deployment, API version, and temperature. So we'll be using model GPT-4o, and this is the model version. Now, where exactly is this model? Let me go ahead and show you that. So if you missed this particular previous video, go ahead and check out that, where we have created this Azure Foundry service and we have deployed the GPT-4o model. And that model is available in the deployment sections. Again, it is very simple. You need an active Azure account, and from there you can create this particular service. And in that service, you can create a GPT-4o deployment. Okay, the model deployment is very simple. You can go to these deployment sections, and you can see here we have deployed the GPT-4o model, or you can click on this deploy base model, and you can select the variety of models that are available in this list, and then it is very simple. You just need to select the model and you need to confirm and confirm the configurations, and it will be done. Okay, so for this particular GPT-4o model, we need to grab the Azure endpoint. So this is the endpoint that we will be using. So let's copy this, and we need to add that Azure endpoint. But how exactly we need to add? We need to set that as an environment variable. So Azure OpenAI endpoint. So let's go ahead and copy this endpoint, and we can go ahead and add that endpoint here. Okay, we have added the endpoint. Now the next step is adding the Azure OpenAI key. Again, similarly, we need to define the environment variable Azure OpenAI API key, and that key you can grab it from here. So this is the key. Let's copy that and let's pass the key here. Okay, so we are done now. So this is how we have defined the large language model. So let's execute this. Now, we can go ahead and build these tools. Now, these tools are nothing but the Python functions. It is very simple. We just need to write the Python functions in order to accomplish this particular task, and then we can register these Python functions as a tool to our graph. So let me go ahead and quickly add the first functions in order to calculate the price. Okay, very simple function, check price. Make sure you are adding a proper doc string. So this doc string is going to help our agent, this particular agent, to call a write tool at right time, because it will understand what is the input that is required for this particular tool based on these arguments. Try passing the examples as well, and then it will also help our agent understand how exactly it is going, what response it is going to return. So we have just given prices in Indian rupees. Apple 30 per piece, then milk is 60 per liter, bread 40 per loaf, and then we have chocolate 100 rupees per bar. Those are the price, and whenever user is passing item, or agent is passing item, it will go ahead and get the price of that particular item. Very simple function that we have written. Similarly, let's go ahead and add the add to cart function. So again, add to cart function is again very simple. It's a very simple Python code. You can see we have written a function add to cart. We have added a proper doc string, and it is just going to return that, okay, added the particular quantity into item to your cart, meaning item and the quantity that we are adding. So again, this is just the dummy example that we are covering. This code you can replace it with your, let's say, SQL database, where you are going to actually going ahead and updating the data. So in the project that we are going to see, right, these dummy examples, we will be replacing it with the actual examples. And the last part is to calculate the total price. So this is the function which is responsible to calculate the total price. Again, it is just going to take a summation, and then it is going to return that sum. Very simple three functions we have defined, and these three functions are nothing but these tools. But currently these are just the normal Python functions. Let's convert them into a graph or LangGraph tools. Okay, before that, now let's go ahead and import the necessary dependencies for building the graph. So again, uh, from python.display, this is in order to plot the graph. Then we'll be importing LangGraph checkpoint memory in order to save the memory. Then the message state in order to pass the messages. So these part we have already covered in the previous videos. Then LangGraph start and state graph in order to define the workflow. This is a standard workflow that you can directly import from LangGraph, and on top of that you can keep adding your edges and nodes. And then tool conditions and tool node is required in order to define the tools. And then the AI system message, all those basics details are required in order to start the conversation. So first of all, let's go ahead and define the system message. System message is very clear. You are a helpful shopping agent that help user check prices, add item to their cart, and calculate the total bill in Indian rupees. Very simple system message that we have given, and we have used the system message from the LangChain core messages. Now, next part, we just need to define the node. Now, node, again, we can define it as a function. So let's go ahead and define the function as agent, but here we need to pass the state because it is going to manage the memory. Tools are not going to manage any memory, right? Your agent is going to take actions where you are calling the large language model. Now, what exactly this particular agent returns? It returns LLM with tools. Is going to invoke system message. This system message we are going to pass plus the state message. State message meaning the message that is coming from the user. For that message, along with this system prompt, it is going to take action. This large language model is going to take action. Very simple. And this LLM with tools we have already defined. Okay, we have not defined, so let's go ahead and define that. Sorry, my bad. Okay, so here we can go ahead and quickly define that. Okay, so these tools that we have created, you can see check prices, add to cart, and calculate total. We need to pass them as a list to our LLM, and we need to bind these tools. So you can see here we have bind the tool to LLM, and that's what we are calling it as LLM with tools. Now, this is how we have quickly registered these tools for our large language model with the help of bind tool function. Very simple. Let's execute this. Now, this part is done. Now let's go ahead and start defining the state. So first of all, we will be importing the base graph structure. So this is our state graph where we have passed the message state. This message state is just nothing but the standard response that the response in which the conversations is going to happen. Basically, it's the message in string format. Simple. We have created a object builder, and now in this builder, we will go ahead and add the node and edges. So first of all, let's define the nodes that we have built. So first of all, add node will be adding agent, this particular agent that we have built here. Simple thing, we just need to give name of the function, and in the add node, second node is nothing but our tools. So these two nodes now we have built, agent and the tools. Okay, so next part again is very simple. We can go ahead and add the edges in order to connect those nodes. So first of all, we have added the edge from start to agent. Start is required in order to start the communication so that your LangGraph knows from where to start the communication. So that is what we have we are starting the conversation with agent node. Then we have added a conditional edge between agent and tools condition. So this tools condition, we have already imported it from the LangGraph.prebuilt. So that we need to pass. And then now let's go ahead and add the memory checkpoint quickly so that our agent is going to preserve the memory as well. So we have created a memory saver memory object from memory saver, and then in builder we are compiling it, and here you can see we have pass interruption method, very simple, and the checkpoint memory. So this is the part that we are learning, adding interrupt before equal to tools, the one that we saw. And with this, now our workflow is ready. Now let's, okay, and I missed this particular part. We have added a edge between tools and agent as well. Okay, so now let's go ahead and plot this particular graph. So this is the code that we will be using in order to plot the mermaid graph. And let's go ahead and execute this. Okay, you can see we are starting the conversation, then we have agent, then we have added tools with interrupt before method, and then we are ending the conversation. So the same thing that we have built here, you can see we have shopping agent and then these tools and ending the conversation, and here we have added the interruption. So the workflow is ready. Now let's go ahead and test this workflow, whether it is working or not. So in order to test that, let's go ahead and add a simple code where we have defined the input message, which is in the format of human message. Let's add a very simple example. How much does an apple cost? And then we are creating a thread. Again, thread is nothing but the channel in which we are managing the conversation history. And again, we have covered that thread in the previous video as well. Then running the graph until the first interruption. So we are running the graph with the help of stream method that we saw in the previous video. Graph.stream, we have passed the input message. Then thread and streaming mode is values. Again, the streaming mode we have seen in the previous video, which accumulates the messages one after the another. Let's see that. And then we are printing the last one message, and pretty print is the just a print function which is going to print proper format. So let's go ahead and execute this. Okay, you can see how much does an apple cost was the question that we asked. Then it recommended, okay, it needs to go for tool calls, and then it has extracted the detail that is required for the next tool to call. And the next tool call, it is defining it as, or it has recognized check price. So it is going to call check price tool and going to pass apple as an input. Let's go ahead and check that. So check price accepts item. That is what it has extracted, meaning it is going to work correctly, and then it will extract the detail that is price 30. But it has interrupted. It is not going beyond that because we have added interruption here. Interrupt before tools, meaning before hitting the tool, we are interrupting. Very simple. So this part is done. Now how exactly we can go ahead and execute it further, because so this is the half baked response. So let's see how exactly we can run. So let's copy this thing and let's pass it. Instead of initial response, we just need to pass none. So if we pass none, meaning it knows in the thread what was the previous conversation that have happened. Based on that, it will continue the conversation afterward. So let's go ahead and execute this. And as we have added stream modes as values, so it will show us the previous messages as well. So previous conversation was this. Based on that previous conversation, it called the tool, you can see, and then it extracted 30 as a response, and then it has generated the final response as an apple costs rupees 30. You can see this is how the interruption is going to happen, or this is how we can add an interruption in between and we can take a call. Now here you can see we have interrupted before calling the tool. We have verified whether it is calling the correct tool, what was the attribute that it is passing, and then we once we are confirm on that, then we have went ahead and executed the further. Okay, so now let's understand a few more examples, and also we'll see how exactly it is managing the states. So let's go ahead and copy the same thing, and this time instead of this, let's pass a simple message. please help adding 10 quantity of apples or chocolates. Let's go ahead and execute this. Now you can see, please help adding 10 quantity of chocolates. It is calling the tool add to cart, again correct tool, and then it has extracted item as chocolates, quantity as 10. Let's go ahead and validate that quickly. So add to cart requires two attribute or argument, item and quantity. Both it has passed correctly. You can see. Now let's understand the state. So state we can get it. So state is equals to, we just need state, and we just need to pass the thread that we have defined. So here we have defined thread as thread only. So let's go ahead and execute this and let's see what is there in the state. So in the state it will show us all the responses. Okay, one thing, one mistake I made, I continued the same thread. You can see how much does an apple cost. It is keeping the previous channel history as well, because here we have given thread as 1. So let's go ahead and change the thread quickly. So let me pass second ID for thread, and let's execute this again. Okay, same response. Now let's go ahead and execute this and let's see what is there in the state. So in the state we have, please help me adding 10 quantity of chocolates. Now we don't know what exactly it is going to call as the next node. But apart from that, you can see a lot of other information that it has added, and we have seen all those information in previous videos, like it is capturing the all tools information, how many tokens it has utilized, the token usage. Then it is also capturing the filtering method, content filtering, the abusive contents, all those things it is checking. And out of this, we just need to see that what exactly it is going to call as next. So let's look for next word here. Okay, next, you can see next is nothing but tools. It is going to call next as tool. So let's check that state dot next. Okay, you can see it is going to call tools as a next object, meaning after this execution, it is going to call tools, meaning whatever we have seen, it is accurate and it is going in the right direction. So let's go ahead and add the further thing. So we can again copy the same thing, and instead of initial input, let's pass none. And let's execute. Now you can see it has whatever stored information, it used that information, and then it has called the tool. And then you can see I have added 10 chocolates to your cart. Let me know if you need anything else. Superb. It is working exactly. So it is working as expected. Now, okay, so this is a manual way of executing the graph again and again. And we have not given any human approval. We have just stopped, interrupted it, and then we have executed it. Let's see how we can go ahead and add the human input and how we can automate this particular flow. Okay, so for that, let me go ahead and add a simple code. Now, we are adding a simple example, add 3 apples and 1 bread loaf to my cart. We have started the conversation with, let's say, thread ID 3. Then this is the first step that we executed, where we have passed input message and rest everything is similar. Now here we have given user input. Do you want me to call the tool? Yes or no? We have given that. And if user approval is yes, then go ahead and again call the same thing. Just we have automated it. And here we have passed none, meaning these two methods we have passed. First, we have passed this method, added human input, and then we are calling this. So let's go ahead and execute this. So, okay, you can see add 3 apples and 1 bread loaf to my cart. So it suggested tool calls add to cart with this item as apple, quantity as 3. And then second one, again it called, it is saying that it needs to call the tool 2 times. Second time it will call item with bread loaf and quantity 1. And it is saying, do you want me to call the tool or not? You can see 3 apples, 3 into apple plus 1 into bread. 3 into apple, 1 into bread. Let's go ahead and say yes. Okay, then it called the tool and you can see the final response, added 1 bread loaf to your cart, because we are printing message -1, meaning the last message. You know, right? -1 meaning last message in the list. But if you print the complete message, you will get that. Okay, here you can see the final message. I have added 3 apples and 1 bread loaf to your cart. So yeah, this is working. So this is how exactly the interruptions we can easily go ahead and add into the LangGraph. Okay, so as we have seen this, now let's jump to the LangGraph Studio. Now, what exactly is the LangGraph Studio? LangGraph Studio is a framework with which you can visualize whatever conversations that is happening, and also you can add these different toolings or interruptions, and you can test it on the LangGraph Studio. So it is again a quick platform for you to test the application, whether it is working fine or not. So let's go ahead and let me go ahead and open my Visual Studio Code. Okay, so I have opened my Visual Studio Code. This is what exactly we have seen. Now, let's see how exactly we can build the studio. So for that, first of all, let me go ahead and create a folder first. Let's say 05 because this is our fifth video, and let me give name as studio. So let me go ahead and create the first file, that is requirements.txt. Okay, then also let me create a .env file. Then let's create agent.py. Okay, we have created these files. Also, we need one more file in order to pass the JSON object. So langgraph.json. Okay, so we have created all the files. In the environment file, we need to go ahead and add our environment keys. So, okay, so let me go ahead and add those environments quickly. So in environments, we have Azure OpenAPI key and endpoint that we have copied from the Azure Foundry portal. In the requirements, let me add the requirements quickly. So again, same requirements that we are using for our code execution: LangGraph, LangGraph pre-built, core, community, and OpenAI. Let's save that. Please go ahead and install the dependencies. So let me go ahead and activate my environment. So I have already created a LangGraph environment. So environment creation is very simple. If you are new to that, just type conda create -n and the env name, let's say LangGraph, and hit enter. If you want, you can pass Python version as well. So once you hit enter, it will create the environment for you. I have already created that, so I am going to go ahead and activate that environment. So activation command is conda activate LangGraph. This is my environment name. Okay, you can see the environment has been activated. Okay, so let's go ahead and start writing our code for python.py. So whatever code that we have built here will be utilizing similar code. So let me go ahead and add that in front of you itself. First of all, let's go ahead and copy these things. And we need to remove this because we have already added that as an environment variable. These things we have added. Let's copy these tool functions. Okay, we have added all our tools. And here we have created the LLM object. Fine. And then let's copy this part as well. Okay. So we have added all our code. Just few changes that we need to do. Let me take these imports at the top level. Okay, fine. You can see all the dependencies have been installed, so we don't see any error. Okay, so only one thing we need to remove from this particular code is that the memory part, because LangGraph Studio manages the memory defaultly. So we just need to remove this particular object that we have created, and also we now need to pass it to the checkpointer here. So first of all, let me remove both the things. We will be building a simple workflow without interruption. So let's remove this. And again, we no need to display any graph. So I'm removing this particular part. So this is the function that we have written. Okay, so that's fine. Now, in order to execute this, so we have added all these details. Now, in order to run the LangGraph Studio, because this we are building a LangGraph Studio, you just need to define one particular format that we are going to define in the LangGraph JSON file. So let me just add that particular format. Again, it is very simple. You can see we are adding Docker files as empty. We are not going to use any Docker. In the graph sections, we have added the agent.py, and that is our actual graph. So this agent.py, which is in the root folder, you can see that's where we have given this particular dot and forward slash, indicating it is a root folder or in the same directory, not root folder, it is in the same directory. Env, we need to define the path of env. That is what we have given. Again, it is in the same folder directory. Python versions, you can pass latest version. That is fine. I have given 3.11. And dependencies, you just need to hit dot so that it will find out the requirements.txt and automatically install that. This is the project structure, standard project structure as per LangGraph. With this, you have already enabled the LangGraph Studio. That simple it is, because LangGraph Studio is very specific to your project. So you just need to make sure that you are adding the project into .py file. You are defining this particular structure, adding the requirement and env, and you are done. Now, how exactly you can run this particular LangGraph Studio? So in order to run that, you need to use one command, LangGraph dev. Just go ahead and hit this particular command. Config path langgraph.json does not exist. Okay. Sorry. I'm not in the correct directory. So first of all, we need to switch to the right directory in the studio. And here, uh, so if you see now, we have all the files available, .env, agent.py, langgraph, and requirements.txt. If you have not installed the requirements, just use pip install -r requirements.txt and it will install the dependencies for you. You can see all the dependencies have been already satisfied for me. So let's type the command langgraph dev and it will open the LangGraph Studio for us. Okay, you can see it is saying that LangGraph, welcome to LangGraph. This is your API. This is where your studio is running. And in order to access the docs, you can go ahead and check that doc. This API we will be consuming. Let's say if you want to consume this particular LangGraph Studio API and you want to add any, let's say, interruption mode, add new agents, you can do that. We'll see how exactly we can do that. But first of all, let's go to this particular link and let's open the link. Okay, you can see it is taking us to the Langsmith portal, and on the Langsmith portal, we can see the graph that we have built. Okay, failed to initialize the graph studio. Let's see what is the error. Okay, there was small issue. The environment file was not saved. Now you can see the moment I have executed the LangGraph dev, it has opened the LangGraph Studio for us. So it is saying that, okay, Langsmith API key is not added. So that's fine. It is not required for now. Okay, so this is the workflow that we have built. We are starting the conversation, then we have agent and ending, and then we have tools. Now from here, let's go ahead and test this. Let's pass some human input message. So let me ask very simple question. What is the total if I buy 2 apples, 1 milk and 1 chocolate? This is the simple message. Let's go ahead and hit submit. Now we have not added any interruption. Let's see how exactly it operates. So first of all, it called the agent, then it called the tools, pass the response to the agent, again call tools. Let's see how this happened. First agent check what agent is looking for the tools. It knows that, okay, these are the 3 items that it needs to find out the price. Then it called the tool. So first you can see it called check price tool for apple, milk, chocolate. Then for apple, the price is 30, milk 60, and for the chocolate, it is 100. Then that response, it passed to the agent and agent knows the prices in list. Now it knows that it needs to call the total tool. So you can see calculate total cost. It has passed this particular list and then it has done the addition. 60 plus 60 plus 100. 60 because we have 2 apples, 30 plus 30, right? That's where the total final price is 220, which is correct. And then agent has given the price of 2 apple, 30 each, 1 milk rupees 60 and 1 chocolate 100 is 220. Accurately it is working, but we have not added any interruption. Now you can add the interruption from here itself. You can see you have this option interrupt before. If you enable this, it will interrupt the tool, or you can go ahead and define that interruption in the function itself. Whatever builder that you are compiling here, you can just pass that interrupt before, and then here you can pass tools. And let's save this. You just need to save this, and let's ask a very simple question. So if you can see now under the tools, you can see the interrupt before is enabled. So let's go ahead and put the message. Let's say, can you calculate the bill for 1 apple, 1 bread and 2 chocolates? Let's go ahead and submit. Okay, so you can see after the agent, it has stopped and it has requested for human input. So here we can go ahead and click on continue so that it can go ahead and call the tools. The moment I click on continue, first it will call the first tool that is required in order to calculate the price. So you can see under the tool sections, so under the age section, if you can see, it has called the check price for these 3 individual items, and then it has calculated the list of price. And then again, the moment I click on continue, it will call the total price or total calculator. And you can see in the total calculator, then it will go ahead and calculate the total cost. You can see it has calculated total cost as 270. So the total bill for 1 apple, 1 bread and 2 chocolate is 270. So this is how it is adding the interruption. Now, you no need to define the interruptions at the code level. Here you can see, as you have defined the interruption at code level, you can see you don't have option to disable it again, right? You can add the interruption after, but you cannot enable or disable this particular option. You can add that interruption from the studio itself. Let's say if we want to stop after the agent, so you can go ahead and enable after. So, okay, so to test that, how you can add the interruptions on LangGraph Studio, let me go ahead and remove this interruption from here. Let's save this workflow and let me rerun the workflow. Okay. Now this is the workflow. You can see we have not enabled the interruptions anywhere. Let's add the interruptions at the agent level. And let's ask the question. What is the price of 25 apples? And let's hit submit. Okay, you can see the moment we submit, it is waiting for the confirmation from human at agent level itself. You can see at agent level. Once you continue that, then it will go ahead and call the tools and generate the response. Now it will not wait for tools, but once the response is generated from tools, it has checked the price. Now it is has passed that response to the agent. So it will again ask the human input. Okay, continue. Now it will call the calculate the price for what was that bread, right? So it will. Okay, it was only for apple. So you can see the price of one apple is rupees 30 and the cost of 25 apples would be 750. So that's how this LangGraph Studio is working. Okay, now the last part that is pending, how exactly you can call these APIs into your notebook itself. So again, it is very simple. So if you open your notebook, so let me quickly go ahead and add that particular part. So now we are going to see this particular part. We will be enabling these breakpoints with the help of LangGraph API. Now this API is nothing but you can see this particular API. We just need to add this particular API into our workflow. So we just need to call that particular API. And in order to call that, we just need to use this particular code. From LangGraph SDK, we just need to get the get client, and in that client, we need to pass this particular API. Once you pass that, okay, you can see the client is created, and now you can add the function similar way we have added previously. You can see message you can pass the price of 10 apple. Thread you can create and you can pass input message, and then you can chunk the data. Okay, so you can see that after the execution, you can see what's the price of 10 apples, and then it has interrupted that. Now let's go ahead and execute the further step. Again, you can call the same thing, but this time you just need to pass instead of initial input, you just need to pass the none and you can execute that so that it will go ahead and extract the price information. So you can see the final response, the price of one apple is rupees 30, therefore the price of 10 apple is 300 rupees. So that's how now it is talking to the API that we have built, this particular API, the one that is hosted here. You can see it is calling this particular API in order to generate the response. So yeah, that's how with the help of LangGraph Studio and LangGraph, you can go ahead and quickly build the application. So if you like this particular video, please go ahead and like the video, subscribe to my YouTube channel and share it with your friends. I hope this was really helpful for you. And if you're having any questions, please feel free to drop your questions in the comment section below. So yeah, thank you so much for watching this particular video and I'll see you soon in the next interesting video. Thank you so much.